everyone. Thank you, Robert, to introduce me here. I can see a very energetic, very enthusiastic crowd over here. As Robert has already introduced me, I work as a BIM manager with Arab Engineering Bureau, and at AEB we are really pushing the boundaries to adopt and utilize building information modeling in as many projects as possible. So here today I am going to talk. Okay, one more thing that I am the victim to present just after the lunch. So I hope that no one is going to sleep. Please keep awake. Thank you. So my topic today within technology is BIM in the cloud. And lots of people know about it, lots of people do not know about it, and some people, they are just like confused whether to believe it or not. So myth or reality. Okay. So gradually we will come to know about it. Understanding, basically we are talking about BIM in cloud, and lots of things regarding BIM starts with Revit. So it is very important to understand that how Revit work sharing environment is formed and what are the different terminology we use within this work sharing environment. So starting with central and local files. So most of you who are working with Revit, they would have heard about this term. If not, then let me explain these things. Revit work on central and local file system. Central file is something which is stored on Revit server, and local file is something which you open from the central file and save it on your local machine or somewhere else. But there is always a connection between central file and local file. So a file can be saved as a central file when worksets are created. Worksets are kind of a different set of responsibilities created in the form of a set within Revit and assigned to different people. Soon you create a workset, a file becomes a central file, and that can be saved and can be utilized by other people who can open the local file, a synchronized local file on her computer to contribute to the central file. Work sharing. So work sharing is, as I spoke before, work sharing is enabled when a central file is saved on the host server. Like other people can also open the same file. The work sharing is enabled. Multiple users may open a local copy of the central file. Revit maintains a live link between local and central files and communicate changes both ways. Reload latest updates the local file for any changes done by other users. For example, just take a stadium project. Siddharth is very happy with that. So stadium projects, we have got multiple people working on just architecture model, and we have created work sets. About 10 people are working on the same model. So whenever a person opens a local file and he wants to see that what other people have done in the same model, he just presses reload latest, and it uploads or it updates the whole model, showing that what other people have been contributing to the same model. Synchronize the central, it updates the central file. Whatever changes or whatever updates you have done to your local file, when you press this button, synchronize the central, it updates or it transfers all those changes only to the central file, and other people can see those changes. So these are the small tools, reload latest and synchronize the central. Pressing these things brings you the latest changes in the model. So that is something about work sharing. Now Revit server over LAN or WAN. So as you know, Revit server is where we save the central file. How it is connected to different users is via local area network or wide area network. Local area network, it does not require internet connection, but wide area network, it requires internet connection. This setup allows multiple team members to access and modify the model files at the same time. This also allows team members located at different offices to collaborate and work on the same file. So for example, if there are two offices of AEB, one is in Central Doha and one is in Wakra. So we can connect these two offices using wide area network, and people can contribute to the same file, but we need a very high bandwidth internet connection. So the limitation of this system is the geographical distance should be less than 500 kilometers. More than that, people are like different IT, especially they have got some level of success to keep on working on this thing without any loss of data and time. But the limitation is 500 kilometers. Only members set up on WAN can work on the project. No outsiders allowed. What that means, that if you have got collaborators, if you have got sub-consultants who are contributing on the same model, you cannot use WAN for that purpose. Until unless you invite them to sit in your office and use your system and contribute to the model. So this is how local office setup works. It's a typical location. You've got user 1 and user 2. Both have got the local files. They work on the local files, and the work is updated on the central server, where you can see the main model resides here. So that's a typical Revit setup for one entity office. So that's about Revit work setting environment. So I'm sure Laura is going to explain more on this topic much more in detail. So I'm not going to touch lots of things, otherwise she will say you're competitive. Right. Next is BIM in cloud. If the work sharing environment we discussed before, if we move the whole thing on the cloud, we are talking about BIM in cloud. Okay. This is how our cloud looks like. Are you sure? No. Okay. So, what is cloud actually? Cloud is used for two purposes. One is just for storage. You use Dropbox, Google Drive, Apple Drive. There are so many independent vendors who are providing this kind of services where you can store your files to access it from anywhere around the globe through any medium. Next is for computing. Examples are online photos, video editing tools such as Google Photos, cloud computing, cloud rendering, video, Google Spreadsheet, etc. They are all working on cloud computing system. I'm sure lots of people would have edited a photo on Google Photos and have uploaded it. So that application is not sitting on your computer. That is obviously installed on some remote computer, maybe in California or Australia, and you are using that application through your computer to edit that photo. So that is what we call cloud computing. Basically, your email is the most basic form of cloud computing. Everyone is using that. So cloud can be explained as a remote service of sharing computing resources to store data and perform complex jobs without a need of resourceful computer. So that is our cloud. Next thing is a little bit more literal definitions from Wikipedia, from more IT books. Cloud computing is a model for enabling universally available, convenient, on-demand access to a shared pool of configurable computing resources. At the core of cloud computing, storage is converged. At the core of cloud computing is the converged infrastructure and shared services, bringing economies of scale into fruition for IT services. So, just like electricity, water, you open the tap, you are getting the service. The same thing is happening with cloud computing. You are accessing it, you're just turning on your computer and activating your internet. You are using a cloud service. Essentially, wherever you have internet, you may be directly or indirectly using cloud computing or storage. Now, it comes to private cloud. You would have heard about this term as well. So, in that massive set of group of clouds, if you want to have your own cloud, what do you do? Any individual or business entity can purchase its own private space from the service providers such as Amazon, Microsoft, and there are so many other organizations who are providing the service, and they give you space within their whole infrastructure to save your own items there. So that is more secure because they have encrypted it in their own way, and it is as safe as any other IT infrastructure. So that little cloud, you can call it as yours, mine cloud. So some other thing about cloud is terminology. It's very important to understand some of the basic terms which I will be using in my presentations. One is bandwidth. Everyone knows 10 Mbps, 25 Mbps, or if you go 10 years ago, you would get like 250 or 256 KB per second. So that was kind of a speed. Now in Qatar, residential connections can get 25 Mbps per second speed. That's what we call bandwidth in very, very simple terms. Latency refers to how fast your data transfers from one location to other. So if you have stored your cloud items or your items in the cloud, if it is taking a certain amount of time to download or to open on the computer, that is what we call latency. It is measured in milliseconds. For cloud computing, The ideal situation is 50 milliseconds, and it can go up to 150 milliseconds. So, but ideal is 150. Ideal is 50 milliseconds. Next is server. As I explained before, the server is somewhere you store your central file. But when you're talking about cloud, again the server is playing that role of hosting your files there. Jitter, in another term, the variability in latency is called jitter. Sometimes you're getting 50 millisecond speed, sometimes you're getting 100 milliseconds, sometimes you're getting 75 milliseconds. So that is causing, some of you may have faced this situation before, that your mouse click faces a jitter on the screen. So that happens because of the variability in the latency. So these are the very, very common terms in cloud terminology. And from here, we are going to discuss three types of cloud systems which are in use and under development. So type 1 is the most basic one, LAN and WAN. I've already given you some idea about this. And it is basically limited to one organization or 2 or 3 satellite offices within the same city or country, basically. So how it works? Private work sharing environment is first established over local area network (LAN). To connect multiple workplaces to a single network, wide area network is required. Now, if you want to connect 2 or 3 buildings in the same vicinity, you are going to establish wide area network, and this requires high internet bandwidth. And headquarter office may act as a data center where all servers will reside. So this is how it works. You have got your local office in Dubai. The typical setup, user 1, user 2, user 3, they're all working on their local files and they're saving it on their central server. And then with the help of an accelerator, which reads the cache memory and transfers it to the data center. So you establish a data center here, which is a kind of your private cloud, and you are transferring the cache memory or your central file to the data center. Similarly, you can connect Sharjah office if you have there, and you can connect your Abu Dhabi office if you have there. But if you notice here, I am using Dubai, Abu Dhabi, Sharjah, but not Doha. Because soon you change a country, there are several obstacles in terms of bandwidth. And then though Dubai and Doha, they are only I think 200, 300 kilometers within the limit of 500 kilometers, but since we are talking cross country, you don't get that bandwidth, and then the issue like jitters and latency will be prevalent. So lots of benefits of having this type of system on WAN. Same organization within 500 kilometer range can work on same project. Private cloud storage, huge time saving, no uploading and downloading of the data every day, no duplication, and quite really less room for error. But on the other side, there are some limitations as well. As you know, range is 500 kilometers, and you really need high bandwidth requirement. Then there are high latency issues if the bandwidth requirement is not met properly. The jitters, cross-country connection causes even more jitters and latency. Time saving mentioned under benefit is not always realized because of high time consumption for opening file instances. This is the most common issue WAN-based system face. Sometimes a file takes up to 25 to half an hour to just open a file, and that one action just takes away all the benefits we discussed earlier. So that was one type. Now type 2 is BIM data on cloud and the local computing. So here's the scenario. We have got an office, AEB office in Doha, okay? And the same setup we discussed before. User 1, user 2, user 3, they are all working on their local files, and they are saving, all the changes are communicated to the central file in the server. But scenario changes, and AEB has got more offices in Muscat, more offices in Kuala Lumpur, outsourcing their work, and an office in Manila. So we have got the situation. We want to share the files easily. So what we do, we get a cloud storage system and we save our files there. So our offices in Muscat, Kuala Lumpur, Manila, they are connected. They can download the same model. But the point is that they cannot work on the same project at the same time. So to come up or to remove this limitation, there is a technology which is coming up, which replaces your Revit server. Panzura is one of the solutions which provides a kind of console It's a very high configuration console, about 1.3 terabyte of cache memory, an advanced Xeon server, very advanced routers, which like if you have 10 MB per second of connection, what happens in a typical environment, that bandwidth is distributed to per user. So 1/8 of the bandwidth reaches to a typical user. In this scenario, with this machine, what it does, it provides a full bandwidth to each user. If you have got 10 MB per second speed, then each user will be able to use that bandwidth. So after having set up this type of setup, what I can do, I can save, I can connect to my cloud storage and transfer my central file to the cloud storage. Now, what this thing does, that it just transfers the cache memory to the central file instead of downloading or uploading the whole data. So this way, users don't even realize that they are working on a different system. So, but this, for example, BIM system, it stores the model, and whenever it gets the time or whenever it sees the free bandwidth, it just transfers the data to the central file. Similarly, all your offices in Muscat, Kuala Lumpur, Manila, they can install this same machine and they can connect to the cloud, and they can do real time work sharing. So this is what I call international real-time collaboration and local computing. So how it works? Users don't even realize the change setup. File naming, encryption, box saturation, central and local file system, they all remain same. Nothing changes there. Data created is first stored in the cache memory of the console and is then saved over the cloud. After the first save, it only communicates the changes in the model to the cloud and works in the background. Panzura white paper states that it provides full bandwidth to each user. Though I have not done the first-hand testing or experimentation with Panzura, but the way I have been shown the demonstration, it looks like, okay, this thing really works. Multiple users from different geographic locations from the same discipline can work on the same model at the same time. So why I'm saying same discipline? Because if you are trying to open a link file, it will not open. If you are opening a link file, it will break the link. So it's quite a complicated technical jargon I'm using here. But don't worry too much about it. What it says that it allows, if there are worksets on the file, it allows multiple users from different locations to open the same file using Panzura console and store it in cloud and work collaboratively. So again, lots of benefits: rapid file access and easy collaboration. Local cache memory of 1.3 terabyte provides full bandwidth to each user. Users from all connected offices can work on real-time collaboration, huge time saving, high security data, minimizes bandwidth and latency jitters, all those things. But there are some limitations as well, such as it is a very expensive setup. So offices will be very reluctant to deploy this technology without having it reviewed properly. Limited collaboration with only those with a similar setup. So if you have got another sub-consultant somewhere in Europe and you want him to work on your project as a live collaborative effort, he cannot be part of this thing. He will also have to install a similar setup. Most suitable to Revit work sharing environment, other BIM software may not work, best suited to connect satellite offices like we have at AEB. So that's type 2, BIM data on cloud. Now the type 3 is BIM hardware and software on cloud. How does that sound? How can you transfer your hardware to the cloud? So far we have learned, okay, I'm only transferring my data to the cloud, and through using a very high configuration technology, I am using cache memory and transferring the changes in the model, which is transmitting to the central file on cloud, and then it is transmitting to other users. But here I'm going to talk about hardware on the cloud as well. How it works. BIM cloud computing is a technology where the Revit interface is accessed through the internet browser and connects to a remote private cloud with the help of username and password. Same like you access your Google Photos, or you access your Flickr photos, or any online video editing tool. What you do, you just log in with your username and password, and it gives you the access to all your videos stored there, and you can use that application to modify your video or other BIM programs in the cloud server. Basically, we are talking about virtualization of application. So biggest benefit here is that you are not running after your Revit licenses to get it renewed every year. One of that benefit. And the second benefit, you will notice that you are not talking about large IT setup in any office. So here's how we do it. AEB, local office in Doha. Now what we have here, we have only user 1, 2, 3 and 4 with their ordinary machine. Okay? Now they connect with a cloud computing services such as Advanced 2000 or Stratus. Advanced is in North America and in Canada, and Stratus is in Australia and New Zealand. So they provide you that service. They have got all high level of hardware and software setup, and they give you the access to their system. So this is the cloud, hardware, software, central file, local file, all is located on this cloud. You have got your local and central file saved here, and how it works. Cloud host server works as a one-stop solution. All software are installed at a remote location. Whole Revit work sharing environment moves to the cloud. So whatever we were talking about, user 1, user 2 with his own local file and then accessing the central file, it all goes in the cloud. User access is provided through login credentials, same like your Yahoo or Gmail login. Users can access the remote server and cloud computing through any internet browser. That means we are taking away the limitation of whether using Microsoft Windows or using Apple. If you have got a browser, be it Chrome or Internet Explorer or any other browser, you can access it. Files may be saved on any independent or private cloud storage location or at the same remote computing host location. So that gives you the more flexibility that if you already have a cloud, your own private cloud, and you don't need to buy another cloud, you just connect that cloud system to this technology, whether Assembler or a Stratus. Now, you have got Office in Muscat. Same thing, you just provide your users a very simple machine, maybe just a laptop, which they can take home, or a very simple machine without any extra efforts for high level of hardware configuration. Same thing happening with Kuala Lumpur and Manila, but I've got a big line cross over there. Can anyone guess why? Because every technology has got some limitation, and this technology has got a limitation of distance less than 2,000 kilometers. If there is a distance more than 2,000 kilometers, this technology does not work. So you can access the cloud, you can download the models, but you cannot work in real time. So again, there are certain benefits and limitations. Using dynamic resource location, multiple Revit sessions can run in parallel using high-end shared computing resources. So what I'm saying here that all those renewal of licenses of Revit every year, you just get rid yourself of that situation, of that problem. Operating system independence, virtualized application. You use Apple, you use Microsoft, you use Android, anything, everything will work. Cost per user Revit establishment is much smaller because you are renting the software, not buying it. Security, virtualized applications are isolated from client's operating system, thus reducing chances of crash and nearly impossible for malware attack. Achieve BIM collaboration in real sense. That is really all your users, all the people connected to the project, they are working on the same model in real time. With any device, for high PCs, session portability, meaning you can ask, it is not very good for the people who are working in the offices because boss can call anytime at your home and ask him, look, there's a problem with that model, open it through your browser and fix it. So that means you may be at your toes. Universal access, all you need is an internet connection. Scalable means if there are more users, more servers can be added at the host end. Printing over long distance might be a challenge, that's a limitation. Technical fault at the server will affect all users. Require internet latency to be less than 150 milliseconds, ideal is 50 milliseconds. Maximum range is 2000 kilometers. Internet blackout means everyone is rendered useless. No one can work. Users in the range of more than 2000 kilometers can still access the data but cannot use the application. So certain other things which goes as a limitation, but I really like the system because if it is available in the Middle East, we can really connect all our sub-consultants, consultants within the Middle East and work virtually on virtual applications on real-time collaboration. So I'm running out of time, so I'm just trying to push through the slides. I'm almost done here. Actually, I'm done. Thank you. This is the cloud bit of reality. Thank you for your clapping, but I got another thing here. Doha BIM User Group website. Sorry, there's a typo there. So, as most of you would know that we have Doha BIM User Group. We call it debug. We are very pleased to inform you that we have just launched its website, qbim.org. And I really thank Nikki from Greece. He has done excellent efforts to launch this website. And then we have got Mahmoud. He has put up some legal terminology in terms of constitution. And that is also going to be floated on this website. I also thank Qatar University, Jamal in particular, and Professor Nashwan Daud to be very active for this group. And we have got lots of plans which will be presented on the website. So keep yourself tuned and log into this website, qbim.org. Thank you for your time.